Advanced Algebra, Functional and Graphical Reasons 4.2. Okay, so how to solve a radical equation with one radical. We want to isolate the radical, raise both sides to the index power, and solve. Okay, a radical equation is an equation that has a variable under a radical sign. We've got to do something about that. First example, so we have this variable under this radical. Now it's natural here to subtract 6 first, not a big surprise. Now at this point, this 2 and this 1 is stuck inside the radical, so we've got to do something about that. So what we typically do is, well, get rid of the radical. So we're going to raise it to the index power. The index here is 2, understood. So we're going to square both sides. That voids the radical, but the consequence is we squared the 4. And now naturally, step 3, we're going to isolate x. So we get 15 over 2. Do have to watch out sometimes for values that make the radicand negative when you plug them back in, but we're okay here. Second example, I got the answer already there, but we'll see how we get to this 25. The cube root of negative 5x minus 9 is negative 14. Again, a radical equation, maybe a little bit more obscure here with the 3. But same deal, we're going to isolate the radical by adding 9. Now here we're okay, even though it's a negative. We don't like this negative out here usually, but with an odd index, it's okay. We'll raise both sides to the third power. Okay, and when we do that, it avoids the radical. Now it keeps the negative. Negative 5 times itself 3 times is negative 125, and you can see now where the 25 comes from. Just divide by negative 5. Okay, a third example. So here, now we sometimes see this where we have a radical equation, but there's this x on the other side. And this is problematic. We are already isolated here, so we go ahead and square both sides. But in so doing, we have to FOIL this out. Okay, you can't just say x squared plus 81. Okay, so we're going to multiply that out. Okay, and eventually we get x squared minus 18x plus 81. By now, we probably should be able to factor that out. Now, this is what we call a quadratic equation. Quadratic means highest power 2, and particularly when you have an x squared and an x, you're going to want to get a 0. So we're going to move this x over here, and we're going to add this 7. Okay, and so what that does is makes negative 18 minus 1 is negative 19, 81 plus 7 is 88. Now, you could use the quadratic formula, you could use a graphing utility, but the standard here, if you say a quadratic trinomial like this, with the highest power 2 and 3 terms, particularly if there's a 1 right there, this is usually a factoring problem. So we need to know how to factor. One or two numbers that multiply to 88 but add to negative 19. Okay, so think about that. Be 11 and 8. Okay, so x minus 11, x minus 8. We now use the zero product property, which states if two things multiply to give you 0, then one of those has to be 0. That's the only way you can solve it. So if I set x minus 11 equals 0, that gives you x equals 11, and also x equals 8. But notice I struck out the x equals 8. This is called an extraneous solution, which is an extra solution that's sometimes sort of created in the solution process. The reason this is extraneous is if I go and back substitute, if I plug the 11 in, we're fine. 11 minus 7 is 4. The square root of 4 is 11 minus 9 is 2. No big deal. If I plug an 8 back in, we're fine on the left-hand side. 8 minus 7 is 1. But the square root of 1, it's saying is negative 1, and that's not true. So particularly, we need to check the side that's not under the radical and make sure it's non-negative. But 8 causes it to be negative. You sometimes see two radicals. Get one radical per side, raise both sides index power, and just solve. Again, you see this answer prematurely there, but here we raise both sides to the fourth power. So what we're going to do is, or fourth root rather, so we're going to raise to the fourth power. And that just gets rid of the radicals at the same time, and we go straight to 6 here because if you subtract x to this side, you get plain x. If I add 9 up here, I get 6. And 6 is okay because when I plug it back in, even though it's an even index, we get 2 positive. 6 minus 3 is 3, and 2 times 6 is 12 minus 9 is 3. Okay, the standard here says solve radical equations in one variable and give examples showing how extraneous solutions may arise.